Hi everyone, I'm volcanologist Dr. Janine Kripner, and this is my guest.
Hi, my name is Aaron Marshall. I'm a volcanology PhD candidate at Boise State University.
Thank you so much for joining me. You are studying something that I'm pretty excited about. You're studying mafic, so we're talking about more basaltic andesite magmas, large mafic explosive eruptions. So for people that have been following our previous videos, you'll know that the runnier the magma, or the less viscous it is, allows gas to release from the melt much more easily. So therefore we don't have this gas pressure being built up to produce these large explosive eruptions. We see that in more silica-rich, more viscous, or more rhyolite, dacite, andesite magmas. But you're looking at basaltic andesite, which has produced enormous explosive eruptions. So can you tell us a bit about that and what you're doing to understand why that is even possible?
Sure. So our research team is working at Yaima Volcano, which is in southern Chile. And there's deposits preserved around Yaima from a very large basaltic andesite explosive eruption. The estimated volume of these deposits is 24 cubic kilometers of material. And to kind of put that into some kind of perspective, the now famous 1980 eruption of Mount St. Helens produced a deposit of about 1 cubic kilometers of material. So these mafic volcanoes can clearly produce these large explosive eruptions that rival their high silica counterparts. And these are rare. They don't typically erupt like this, but we see in the geologic record that they do. And some recent work by other researchers has shown that all mafic volcanoes have the ability to shift their eruption style and erupt as these large explosive events. So we are trying to understand, how did that happen at Yaima Volcano? This is a very nice example of an eruption that we can kind of go out in the field, collect lots of samples, and investigate those samples to understand a phenomenon not only at that volcano, but then apply what we find there to other mafic volcanoes around the world.
Wow, so you're looking at the bubbles. So that's when we have these growing gas bubbles inside the magma as it's rising towards the surface and erupting, and also the crystals that have grown inside that magma before it cooled into solid rock, right?
Yeah. So when we collect samples in the field, we can collect what we call pyroclasts. And what they are is they're small frozen pieces of magma that were deposited during the eruption. And we can take one of those clasts, say my fist is one, we can take a slice through it and actually look at it under a petrographic microscope or a large scanning electron microscope and look at very high resolutions and magnifications at the bubble network and the crystal network. And what we're able to see then is we can quantify not only the amount of bubbles that are preserved in the sample, but what their geometries are like. Are they nice spherical bubbles, or are these bubbles very kind of tortuous? And these geometries really help us understand how is the magma evolving. If we have nice spherical bubbles, we can assume that gas had nucleated out from a dissolved phase and was slowly rising through the magma to escape. But if we have these very, what we call polylobate or branching bubbles, it gives us an insight into the fact that this gas was being trapped. Maybe it was trying to escape, but it couldn't. And one of the things we're looking at as an explanation for that is the crystals. It looks like we see a lot of these bubbles kind of warping around these very, very small crystals that we call microlights. And those bubble geometries are very much controlled by this crystal network. And it appears that the crystals prevented that gas from actually continuing to escape, and seems that it trapped the gas inside of the magma necessary to break apart the magma in an explosive eruption. Whereas typically in a mafic eruption, because the silica is so low, because the viscosity is so low, that gas is able to just kind of percolate on up and escape before the eruption.
Wow, that is really fascinating, and I can't wait to see more of your results out of that research. Thank you so much for joining me for this volcano moment.
Thanks for having me.